Cool. Well, my name's Peter Hansons. You've probably seen me around the traps at the data engineering meetup here in Sydney, also at previous DataEngBytes events. In my day job, I actually do a fair bit of data engineering myself. So, it's great to host a panel here today with three fantastic sort of superstars within the field. We've got Lizzie Macneill from EDB. Joe Reis obviously needs no introduction. We've also got Ryan Boyd, co-founder of MotherDuck. So I nearly slipped there, but...
That's how you really feel.
Yeah. Tell us a little bit about yourself. How about you start with you, Lizzie?
Yeah, sure. No, thanks, Peter. So Lizzie Macneill, as Peter said, I work for Enterprise DB. We're a Postgres company. We contribute over 30% of the code to the Postgres project every year. So I've been working there a couple of years now. It's my first vendor role. Sold out a little bit, would you say? No, kidding. I've had loads of data engineering roles across many verticals. Data architect, systems analyst, ETL pipeline builder, the usual stuff that gets you there. That's me.
Awesome. Joe.
Hi, everybody. Good to see you all again. It's your last year. I'm Joe Reis, recovering data scientist, co-author of Fundamentals of Data Engineering, working on a new book on data modeling right now. Maybe you can get an idea of what that's about in the next talk. Hint, hint, show up. And what else? That's about it. I'm pretty boring. Ryan?
I think you already heard my intro this morning, but co-founder of MotherDuck, previously worked at Neo4j and Databricks and Google Cloud and BigQuery. So a lot of different types of databases, some analytics, some transactional.
Yeah, so that probably is a good segue into our first question to the panel is why do you need different databases?
I think, do you want me to?
Yeah.
All right. Fundamentally, it's different databases are storing data in different ways, and the structure of how the data is stored impacts the performance that you're going to get out of the database and what other conditions you're going to get. And so, DuckDB is a columnar database. Columns are really great for analytics, and because it's super efficient to be able to do large-scale aggregates in columns. I previously worked at Neo4j on a graph database, which stores the data fundamentally as a set of pointers to previous nodes and next nodes and a set of properties. And that just really impacts the type of things that you can do with that database efficiently. Of course, I think many of these databases you could do anything with. You just would be abusing them in some ways.
I guess to invert the question, why not just use one database for everything?
That's a good point.
I think we tried this actually back in the day with the relational database, right? And obviously there's we can talk about relational later. I'll talk about relational later in my other talk. It's a great concept, but it does kind of fall apart when you're talking about things again, like graphs, right, where you need more efficiency or maybe different ways of accessing data. And so it's a matter of optimizing for your storage and query needs. And right now, I think, how many types of databases are there out there right now? Like probably more than there are like atoms in the known universe. And so, yeah.
Sure. Look, from my perspective, obviously coming from a Postgres background, I'm just going to say use Postgres for everything. It's fantastic.
You could do that too.
It's interesting because the reason the Postgres logo is an elephant is because one of the founders of Postgres way back in the day, Michael Stonebreaker, said, you're trying to do too much now with Postgres. You're trying to add too much functionality, too many extensions. You're trying to get it to do everything when, really, it was an RDBMS that was just really good at its job. And the Postgres people, he said, it's an elephant. It's basically a massive elephant. And the Postgres people ran with that. And they put it as their logo and said, nah, we're really, really proud of this. But look, would I put everything on Postgres? Look, my company would sit there and tell me, don't stand up in front of people and say this, but would I put massive analytics workloads on Postgres? No, of course I wouldn't do that. Would I be looking at putting huge data sets of over 10 terabytes on there? Look, I'd be thinking about it. But would I do it? No, it's every database has its place. And while Postgres is a fantastic database, it's not the tool for everything.
It is a good default for a lot of applications, and people, we're actually finding a lot of people interested in DuckDB for moving from Postgres to DuckDB for the analytic workloads. They're still doing transactional stuff in Postgres, but because I think Postgres is a good place to start in a lot of work.
Yeah.
So with that in mind, where have we come from with databases, and where are we headed? What databases didn't work out, for instance?
Come on, Joe, you can be our data historian, right?
Well, back in the 60s and the 50s, 60s, you had, network and hierarchical databases, and you had the relational database. And there's some debate as to one relational will one out, actually, right? Because there's some, I guess, I don't know if you call them conspiracy theories, but talk that maybe it was the vendors, that made it happen, right? It's the IBMs of the world, or which is kind of funny because I've been researching a lot of this for my book. They actually didn't like Ted Codd's original idea for the relational database, but then they did. So, but that obviously took off, right? You don't hear about network and hierarchical databases anymore, and so. But fast forward to today, I would say the big explosion of databases really happened around maybe what the company used to work at Google, right? So they had relational databases and they worked until they didn't, right? And so they had to figure out new ways of doing stuff with commodity hardware, and the same at Yahoo and Facebook and other places like that. So I think you kind of scratch your own itch, and different things happen from there, and you release white papers, and all of a sudden, the world evolves. So that's kind of in a nutshell what happened. You're starting to see the same thing in machine learning now. I think that's like the big renaissance in databases, I think, is there. So
feature stores and stuff, yeah. And so what challenges are there that are dealt with that we no longer have to deal with within the database space, such as, for instance, we've seen this big progression back to, say, relational from NoSQL. Would you like to make some comment on that, Lizzie?
Yeah, look, absolutely. No, I think there was definitely a few years back a huge explosion in the popularity of unstructured data, NoSQL databases, data lakes. A lot of the concepts that we've been talking about all day today. I think we are starting to slowly see a return back to a more structured form of data, and I think particularly in terms of the business value of data and how data is now being seen as a revenue stream and a massive business commodity and a huge asset to businesses. Businesses are starting to think more about, how can we really make the most out of this asset, and how does that relate to our business functions? And when that comes back to data modeling, it turns out relational data and schemas actually have a huge part to play in that make, sort of consolidating that data and really getting value out of it a lot easier. So it's, there's more of a balance these days, I think, between, making the most of unstructured data, but still bearing in mind that modeling is incredibly important.
Which is a great segue to Joe. How do you think why is it that data modeling is coming back into fashion, and what can we expect to see, like what sort of benefits are we seeing from it?
I think we spent the last over 10 years dealing with so I look at things in terms of pendulums, right? You have we'll talk about this more in a bit, but it's like you have the fast versus formal, rigorous versus relaxed. So the last 10 years, we've been spending a lot of time in the fast and relaxed camp, right? And I think we've seen what happens. Have you all seen what happens? Right? A bit of a rhetorical question here. So I mean, I think there's some benefit to it. You can move fast. It's, the old saying, you move fast and break things. We break a lot of things, and now we have to move the other side of the pendulum. You talked about pendulums as well. I think it's, you're talking about scaling out and scaling up, and in much the same way, practices come back in vogue once you forget about them. So it's like finding old religions that die away and come back. So.
Yeah, it's a really good point. We will be coming to the audience with some questions, so I'll give you a bit of time to plan and think about which questions you might have. So please do jump in a second. But with that, I guess the swing away from schema, if you will, and RDMSs and the like was, this rebellion against constraint, if you will. But now we're seeing this turn back to those constraints with good data modeling practices and the like. But I guess there's been a focus on simplicity recently as well, and just getting things done. Can you kind of comment a little bit in regards to that, Ryan?
Yeah, I don't know. It's interesting, the move back to more schema, because I think that the reason that folks like Mongo were so successful wasn't just about scale. It was about representing data in the same format as your application transmitted the data in, right? So, applications use JSON for moving data back and forth over REST APIs, and with Mongo, you could just store that data directly in the database, and it was great. But this is another one of those pendulum swings, is you always get into the question of like, is it better to do the work up front to get the structure that you need, or is it better to do that at query time? And I think frankly, as data engineers and data analysts, like, we just kind of get sick of one way and we switch back to the other way, and get sick of that way and switch back to and it's like this forever thing that the whole world is moving at once in that.
But in your talk, you brought up a really good point about the zero interest rate environment we were living in for the past decade. I think I've been thinking a lot about this. I think this is actually a very significant contributing factor to the move fast, right? Because you had a lot of boom in startups. The mean stack comes out, and for a long time that was what developers used, because why the hell not? Then you find out who knows what mean is. Mongo Express, Angular, Node, and all that fun stuff. Anyway, like, that was in vogue, and then I don't know a developer that literally liked that after a bit. But you had to move fast, right? That's the name of the game. You ain't getting paid to sit around and think about what you're doing. It's true.
It's forever true with you, Joe.
Thank you very much. Me in particular. But I think that is a big factor in it, though. And I think that there was an explosion of new technologies, themselves often funded in a low interest rate environment, to provide new technologies. I think there's some interesting dynamics, right? So.
Sorry.
No, please.
There's a question around time to value with data modeling. Sometimes it requires a bit of an investment to actually see the thing through, because you do have to actually think up front about how you're going to use your data and how it's like, what are the access patterns once it hits the data warehouse. And, now that we're in a non-zero interest rate market, how does that all play out? But does data modeling actually feed into that, where we're actually being considered about our access patterns as opposed to just kind of throwing compute at every problem? Would Joe or Lizzie like to?
I talk a lot. Lizzie can take that one.
Yeah.
Look, I think it's certainly very interesting. I think the barriers to processing data quickly, or sort of spinning up instances to process data quickly, have certainly been collapsing in later years. There's definitely been, for example, the dissolution in some ways of the traditional infrastructure departments, and having to go and ask for a VM so that you can install a database and you can do some work. These days, you're much more likely to have some Terraform code, for example, that's going to, you've got that whole infrastructure as code environment. You're going to get, your environment's deployed that way, and it's yours. It's there. It's ready to go. And I think that's another place where we've definitely got this swing towards the fast, and towards the taking elements out of the whole IT infrastructure level, and just we've got developer and we've got resource, let's go.
Yeah, like the old pets versus cattle argument, right?
Yeah.
So,
I loved that you were referring to like the pain of having to request VMs when like I was thinking about having to request physical machines and end up being told like, no, you don't get any server grade hardware. You get these 2 desktops that are these old desktops that used to sit in. So we'll put them in the data center for you. It's okay. We'll wire them up. It'll work. And
is it Google?
No, this was at the university that I worked for.
That was actually the origins of Google Cloud back in the day.
I wouldn't. I mean,
desktops for Ryan's.
Well, awesome. It's probably time to throw it open to the audience to ask a few questions. We've definitely been touching on sort of types of different databases for various workloads you might have, or anything to do with data modeling. Any questions Any questions on that front? Have we got a mic for this chap up the front?
We can repeat your question.
So, very much on the topic you guys covering, what are your top
Wait, hold on. Stop your question.
Thank you very much.
Right, that's better. So exactly the topic you're talking about, the Pandula and thinking about the data modeling. What are your advices for us as data engineers and managers to go through that journey but not overdo that?
My advice is stick around for my talk at 5.
That's it.
This is all just actually a sales pitch for Joe's talk.
It really is, actually. So I'll Venmo you both some money in a bit. But
So were you referring to sort of going through the effort of, data modeling? Okay, sure.
I mean, I feel like the funny thing is like I'm much more of an anti-data modeler than the other folks perhaps on this stage because
dog.
No, I mean, it's just like when I first started in tech, like everyone was doing data warehousing projects on-premise data warehouses before the cloud stuff. And everyone was doing these data warehousing projects and 98% of them failed because they never got past the data modeling part. And it just like, it put such a black eye, I think, on IT, technology, whatever, as an industry, because they were just known as the people that would spend forever preparing for something that never will exist. And so I do
kind
have
of like
kind of
preppers
similar,
or something?
yes, like preppers, yes. And so I do wonder, like, you know, are we overdoing it by trying to swing the pendulum back towards more data governance and more
I got thoughts
prepared
on this.
modeling? And
What do you think?
Yeah, look, I think data modeling is a fantastic idea in principle. I just think most people are really bloody awful at it. It's what I'm just kidding. Look, I think it is tricky when you're talking in terms of balancing up business requirements with what I see more as data modeling, which is designing something that is going to work at speed. And they're two very, very different things, I think, in terms of the value for business intelligence versus something that's more sort of commercially based that you really, really are going to need some speed out of. I think balancing up those two things with data modeling, it's perhaps that actual, dare I even say, dialectical relationship between those two things that I think has perhaps brought about that change of saying, really, should we bother with data modeling then? Let's just chuck it all in, bring it all out, and everything's going to be fine. Yeah, I think it's very interesting.
Because data modeling came from this constraint that we had with hardware. You just simply couldn't perform the queries back in the day.
It didn't though. The relational model was actually separate from the database implementation of it. It was simply about a way to think about data in the context of rows and columns, right? So when Cod issued his paper on large data banks, that's what they called them back in the day, 1970. It was simply it was almost a math paper, right? So who knows about set theory? That's all it was, right? And how to think about data and relationships, remove redundancies and duplications of your data. That was the essence of it. It wasn't about, you know, and he comes up with the different normal forms, but it was really a concept, I think, that is actually separate from the underlying implementation. I still think it's an exercise people should do, because otherwise, what's the alternative? You have potentially redundant data, right? So when you think about the grain of your data, for example, who understands the notion of a grain? Right, probably a lot of people here. How do you know that you have the correct grain for your data? I'll let you answer that for yourself. But it's exercises like this, thinking about your data, I think, is what these sorts of techniques bring you. It's not necessarily like how do you implement it in a database. It's obviously a concern, but I think it's basically the notion of getting back to thinking about data, which I think for the last bit we really haven't been.
See, I would say, actually, to you on that, I would say storage is cheap. Why should I not duplicate my data to get speed out of a system, given the fact that storage is so cheap? Why should I?
Well, it's more of correctness in your data. Storage is obviously cheap, but when you query it, if you don't know your data, then how do you know what you're querying is correct?
or if you're updating that data, like how do you know that you're not updating it in one place but not another place, and then having mixed results?
Yeah, and that's a shit. But it's more about getting to know your data, I would say. But you're absolutely right. Storage is dirt cheap too. So you You could, but I would also say like we've been in the era of cheap storage and compute and say the separation of both these things. And I can't say that I can't say in terms of a profession that we've actually evolved that much from a practices standpoint. I think from a technology standpoint, we've certainly evolved. I can't say, I think from a practices standpoint, we've actually regressed.
Well, I think we get addicted to the technology side of it. It's just like I was talking about my BigQuery days. Like it was so exciting to query on 1,200 different machines. Did I need it? No, but like it was fun.
Oh yeah, no, it's an awesome vape pen. Trust me, it's great.
It almost encourages you to be a little bit lazy in terms of like writing performant queries at times, and you can just throw a lot of compute at the problem as opposed to actually structuring your data in a performant, thinking about the access patterns, structuring it in a performant way, perhaps.
I mean, how many people have spun up like a Snowflake, like something beyond an Excel because they wanted to throw more compute at it? Anyone? You don't have to raise your hand, but you know. But the vendors love this, right? I mean, they're stoked, so because every time that meter runs, it's money that goes to them.
Yeah.
So nothing against it. I mean, that's just a game that you play.
Question up the back. We love our sponsors here, though.
Sponsors are awesome. Keep 6XL is the future. Run that all the time on everything.
I'd love to hear your thoughts on what are your different views around data vault versus data mesh versus more star schema approaches to modeling.
Wait, what was the first sentence?
I think it's data mesh, data vault, and star schema.
Exactly. What first comes to mind? What are your thoughts? Any particular views that you have around customers thinking about greenfield data platform projects?
What do I think about distributed data architectures? Well, that comes back to also what do I think about sharding in some respects, but we'll leave that to one side for now. In terms of distributed data architectures, particularly this concept of a data mesh, it's very trendy at the moment. I actually don't think it's a new thing. I think those of us who had the balls to run stateful workloads on Kubernetes in a microservices architecture have actually been doing this for some time now. Do I think it's a benefit to the business in terms of revenue streams? Look, absolutely. In terms of this is all related to microservices architectures, in terms of efficiencies of upgrading, updates, maintenance, patching, all of this stuff that can be done on a much more granular level and not have to disrupt an entire pipeline. Yeah, I think it's fantastic. In terms of the actual concepts that underlie a distributed data architecture, do I think it makes teams more efficient because they have more autonomy over their own data sets and don't have to necessarily rely on really strict company-wide governance regulations? Yeah, I think it does help get through some of those barriers. I think it can be difficult to manage in a lot of respects, but I think for me personally, I think the benefits outweigh the disadvantages.
I think two of the things you mentioned, data vault and star schemas, are similar. Data mesh is not similar in that the three things you mentioned. So if the question is, what do I think? Is the question like, what do we think about them like together or like separately? Or that's the nuance of your question.
I think the answer, or the question I'm trying to ask here is, customers are sometimes thinking these things as interchangeable and, appreciate the comment around these maybe being different paradigms. And so if customers are thinking about data architecture in building different data platforms, like what are your thoughts as it comes to thinking about customers going from maybe an on-prem out-of-date application to a brand new modern cloud data platform? Is it distributed computing? Is there a paradigm that you think about in terms of the data architecture that you'd use or data modeling framework?
Yeah, I think, again, data modeling, you have to separate it from the physical implementation versus the conceptual implementation, right? And so, Patrick Cuba, if he's in the audience, he can talk about Data Vault. I know next to nothing about it, and he knows everything about it. So, but data mesh is one of these things where it is essentially it's decentralized sharing of data assets and products, right? So notice it has nothing to do with on-prem or cloud or anything, right? That's simply and that's by design. It's like you should be able to interchange and share data regardless of the implementation details through the notion of what's called a data product. Now, the underlying data in a data product could be from Data Vault, it could be from a star schema, it could be from one big table, it could be from no big table. I don't know. Like the implementation details are left out. How do you share a data product is really what the essence of data mesh is, regardless of location and regardless of the type of underlying, whether it's star schema, Data Vault, again, whatever. And Data Vault and star schema, again, these are just ways of implementing, thinking about, the model of your data, right? So again, you can do this on-prem, you can do this in the cloud. And so I think that it's, again, and again, I'll talk about this in a bit. I'm totally stealing my own thunder here. But just show up at 5. We'll talk more about this. They're all awesome approaches.
Have you seen MotherDuck or DuckDB used in a data mesh implementation, Ryan?
In a data mesh implementation, not called by that name. I think that we've certainly seen it used where DuckDB is being used independently by a number of folks in a team, and then they are joining their results together and such. So they have independent sets of data that they're working with, but I think not by that name or by the strict definition.
I wonder how that would work. Anyway.
Steno tables, perhaps?
We'd all like shared laptops, and then that would be like data mesh, and then or 2 computers.
Yeah, I mean, we're trying to do sharing, like in MotherDuck, we're trying to do the concept of sharing where you basically have a URL that you have your own data in MotherDuck, and you can give a share URL, and other people can attach that share URL, and it represents a snapshot of the data at a point in time. And I could see like that being used sort of data meshy, but the data is still all going to be in the same service. But you could join I have a share URL for an internal data warehouse, and then someone else has a share URL for, I don't know, weather data. How does weather data impact our usage? I don't know.
But I mean, the missing link with data mesh is still the federated computational governance layer, right? That's still. I mean, we're still waiting to see what that looks like. So.
Indeed. Any other questions?
Yeah.
Right here. Okay.
Hi. It's a great panel and great discussion. I think I'm going to labor the same sort of point around data modeling, but more of a question.
I'll just give my talk right now.
I think it's topical. What are your thoughts on the evolving concept of data product modeling? So this is you actually modeling products and perhaps modeling from the consumer perspective. So you're modeling the contracts that Chad talked in the morning. So you're talking to your producers to say, I would like the data like that. So the modeling is, because it's hard, to your point, and you got all these things. Do you think that will have more legs? And how do you sort of standardize it and drive it through patents and things?
I don't.
Did you want to rephrase the question? How do we standardize and drive the modeling practices within the business? From a data product perspective, I guess given that you work with a lot of application use cases.
Throw me under the bus, why don't you?
Absolutely.
We could actually have our panel moderator answer some of these questions too, because I believe you have...
What do I know about data engineering? I'm just asking the questions. Nah, too hard. It's too late in the day. Simpler question.
Well, no, I think you bring up an interesting point, though, the notion of data products. Who's heard of data products? Heard of it? A few people? The definition is still in flux, I think, as well, right? Like, I see some vendors, and they say, like, a shared data set is now a data product. I don't necessarily agree with that, but that's one way of looking at the world. I'm glad that at least, because everything we're doing basically comes back from the world of supply chain. When you look at it, like DevOps, that had its roots in supply chain, data ops, and data products. I mean, inherently, you're dealing with the world of atoms and so forth. So I think it's pretty cool, but stay tuned. We'll talk more about that. That was like the worst non-answer I've ever given to the question. But,
I think you did pretty well.
Thank you. Thank you very much. Modeling metadata?
So metadata from, say, like the information schema of a database or something like that? Like, so for instance, in the use case of a data catalog or something? Well, I guess there are a lot of open source projects that try to attempt that, but would you like to...
Ryan's really good at this question.
Modeling the metadata. Are you saying like trying to find ways to make it more understandable to consumers to try to like from it? Yeah, I'm not coming up with a great bullshit answer on this.
Is it really around? You've got some really great questions, and it's I know, but are you trying to? I've looked into sort of like, I guess, data catalogs a little bit, but are you trying to understand how to make the metadata of databases more interoperable across different applications, whether it's, say, application use cases, analytical use cases, maybe even visualization use cases, and how to sort of bring them together in different multimodal ways or something?
One use case for that, but I totally get it's probably a more philosophical discussion.
I guess potentially neither of these folks claim to be sort of big metadata and data catalog.
Metadata modeling. Let's do data modeling right first, then we can talk about metadata modeling.
Yeah. Awesome. Another question from the crowd up the back there.
But good question. I like your. I like where you're going with it.
Maybe over drinks at the party.
Yeah,
we'll solve it.
Yeah, great panel. Loved the conversation so far. I think I'll take a slight detour, maybe something a little bit more open, in terms of trends and things that are sort of nascent, that sort of we as practitioners need to be sort of very mindful of, especially in Australia, where we're probably not as exposed to some of the things hitting up in the US, Silicon Valley, etc. What do you think are the probably top 3 to 5 things from a data engineering perspective we should be mindful of in terms of upcoming technology changes or trends, and where should we be investing our time over the next sort of 12, 24 months?
I think...
Oh, no, Ryan, you go, please.
Okay. I think, we're seeing a lot of... I think that there's this interplay between economic conditions and the conditions that we have, in our data industry, and we're seeing a lot of desire to simplify the modern data stack, and it's from both the economic side as well as from the usability perspective. So I kind of see that as one trend of like in terms of let's try to not have like 45 different tools in our tool set that we're using.
Shout out to the vendors though, if you're here, we love you.
Yeah, we love you. Well, I'm not saying which ones
all of
to
them.
eliminate. I'm just saying like for all the vendors, it's the other folks that we're talking about. No, I mean I think that it's just becoming confusing and concerning from an economic standpoint, and then makes a lot of these other decisions much more difficult to have so many tools within the stack. So I think that's one angle, and I think frankly we benefited a lot from it with MotherDuck, and well, in particular on the DuckDB, the open source side, like we've just seen DuckDB used in so many ways that perhaps other tools would be used for in the zero interest rate phenomenon world. So we've seen people take DuckDB and use it for ETL by running thousands of Lambda jobs with DuckDB sitting in it to do ETL against their data in S3 or something like that, and then compare those costs to the other tools that they would have used beforehand to do that ETL. And so we're benefiting a lot from it in that way, but I think that overall as an industry, we can benefit from it by just saying, you know what, like at some point, enough is enough.
That's true.
Yeah, look, I think one of the things that I've certainly come across a lot recently is, and it's definitely not a new idea, but I think there's something that's definitely becoming more pervasive with new data technologies, is make a decision up front about the opacity of the technology that you're going to use. Now, there are a couple of different angles to this, but from a basic standpoint, you've got things like, is this technology a black box? Can I improve the performance of it? Things like which different programming languages can I use with it? Make all these, don't sort of get caught out by trying to do both ways and trying to control things, but also using products that are going to be a black box to you. I'd say probably one of the other things is, and I should definitely say this coming from a vendor, is I would say just because it's shiny doesn't mean it's good. And that's probably a terrible thing to say, but that's certainly one of the things that don't get tied up in the hype. Like, see something for what it is.
Elephants are pretty matte, not very shiny. Like,
Neither are ducks. Actually, they are pretty shiny.
Had to thread the sales pitch. Joe, top 3 trends?
Top 3 trends. FinOps, so focus on costs. And I think focus on costs and also figuring out how to make money, right? So now's the time you can go on offense too. I'm not a big fan of playing defense. I think you should be aggressive and go on the offense. It's a very American point of view probably. Go kick some ass. So how do you do that? Get to know the business. This is like the thing you always hear. We need to add more value to the business with data, right? I'm so tired of hearing this, but you should learn to do that. Because the business is expecting a lot from you with a lot less. That's the reality of it, right? The days of, again, being able to spin up 45 different tools, that's probably over right now. The days of intense cost scrutiny is here. And I would also say that, I wrote a blog post about this a few weeks ago on joereis.substack.com. You should go subscribe to it. But I think it was called, no shortage of tools, but no idea how to use them. Or lots of tools, but no idea how to use them. And the notion of it is there's no shortage of great tools out there right now. There's a tool that can solve basically any problem you want in data. But from a practices standpoint, I think we're still in the dark ages, right? Things like data modeling, for example. Don't know about that anymore. And I'm not just talking about data people either. I'm talking about software teams, software engineering teams. Often they're the ones that you rely on for your data, by the way. They've also eschewed practices because they can just spin up a ton of resources and crank out whatever they want. I think practices-wise, they're probably further along. So I'd probably study what software engineers are doing. I'm not saying what they've done is great, but and I think also if you want to see where data is going, my litmus test is look where software engineering has been for the past 10 to 15 years.
That's a good point. I was just chatting with someone from DBT about testing practices.
Yeah.
And they were actually trying to pitch us on ways that DuckDB can make this better, which was kind of funny. They actually did a Loom video that was trying to pitch us on how DuckDB, like a lot of people do try to do some testing of their data pipelines and engineering activities in their local environments, but they have a different database there than they have in production. In production, like it's a Snowflake instance or some other sponsor, and
Snowflake.
On their local machine, that's not what they have. So they end up using a different database and then translating all the SQL queries after, when they're using it there versus prod. And so they were talking about like, hey, there's a lot of value if you can have software that can run both locally and in the cloud. And you probably experience that as well on the Postgres side. That this really helps on the testing front. But then they're like, yeah, but also not many data engineers are really doing real testing.
I think the huge
maybe these are interplayed issues, but.
No, that's just I think the huge proliferation of SaaS services has definitely contributed to that because more and more all this stuff is being outsourced and less of those actual core data skills and core data engineering skills being retained in teams because they're just relying on software services to do it for them.
Mm. Well, with that, we might sort of thank our awesome panelists. Really love the point about more proactivity in data engineering teams, I guess a bit more product thinking, alluding to our awesome questioner over there. Thank you very much, really appreciate it, and to all the questions that we've had today. So big thanks to Ryan Boyd of MotherDuck, Joe Reis, and Lizzie Macneill of EDB. Thank you.